scaled up over the last decades and apply those lessons and those practices and the institutional arrangements for urban redevelopment to adaptation to climate change at scale. So if we can just move to the next slide. As a starting point, I think it's very important to recognize when we talk about adaptation at scale that we are dealing with a moving target, and the moving target is a continuing massive increase in urban concentration in the world. So the figures we're all now familiar with of another 3 to 3.5 billion people needing to be located in urban spaces, or in other words, we will be building expanding urban space for another 3 billion people over the next 40-year period of time. And the history of urban development in the world is one in which the natural risks associated with urban location are externalized. And so you see here not a climate risk picture, but a seismic risk picture of San Francisco and Silicon Valley, which purely illustrates the extent to which agglomeration economies in cities attract capital investment and attract business and people in ways that are totally immune to the natural risks that they face. So this area, for instance, over the next, by 2040, faces a 99% chance of a 6.7 magnitude earthquake, but only in the last decade has begun to do advanced earthquake recovery planning on a regional basis. So the growth of cities around the world as an economic force on the basis of investment is one that's relatively immune to natural risk. And the big challenge becomes, how do we begin to internalize natural risk into a kind of performance feature, in the economic performance feature in our cities and in urban assets? Can we move to the next slide? To illustrate this a bit further, based on a McKinsey study of investment in urban fixed asset expenditures just in China over this 20-year period of time from 2005 to 2025, if we extrapolate the Chinese figures, we can estimate that there's about $200 trillion in investment in urban fixed assets that will happen by 2025. And then you compare that with the pledges for international adaptation funds and even the estimated total cost of adaptation of $1.6 trillion. You see the magnitude of the gap between the extent to which we're going to be expanding our cities in high-risk, natural risk areas and the amount of resources that we're managing to mobilize to deal with those risks. And in Luca's presentation on Copenhagen, we saw an example of this. The top-down models, like this $1.6 trillion in this figure, the top-down models that are used to estimate 100-year damage from rain events in Copenhagen told us that there would be about €2 billion worth of risk over a 100-year horizon. And then, Luca, you gave the example, the bottom-up reality shows us that in 2011, there was actually $1 billion of insured damages from one storm. So I think we massively underestimate the cost of adaptation, but we particularly underestimate the extent to which the expanding risk profile of urban areas around the world will continue as we expand investment in urban areas. Go ahead. So my takeaway on that is that we can't really solve this problem by purely understanding it as an externalized risk that somehow needs to be internalized, that we need to convert the whole strategy around adaptation from one that I would say shifts us from thinking about adaptation to thinking about how we create more resilient urban assets in urban regions, urban districts. And I think of this more as a performance investment, therefore, that we are trying to recruit private and public investment into increasing the price performance benefits that you get from building a building, renting a building, locating yourself in a building in an urban area. So I'll just read that definition here that we use in ICLEI for resilience. It's the ability of an urban area, system, or asset